Hello, I'm Mr. McBrien. This is TEJ20, Turing 2, Inputs and Variables. Hello everyone, I'm Mr. McBrien. This is Turing Programming 2, Inputs and Variables. So yesterday we talked about the IDE and took a quick walk through it, and we talked a little bit about outputs to the screen and commenting. Today we're going to talk about text-based inputs and variables, of course, a location we're going to put those inputs. So we discussed inputs quickly yesterday. Practically no programs work independently of their environment. Most programs interact with users and or devices on a fairly regular basis. So our programs are going to be designed to have these kinds of interactions, but primarily we're going to interact with the user. Input options. We talked a bit about this yesterday. We can interact with the user through a keyboard or a mouse or a joystick. We can retrieve files on a hard drive, and we can do other things as well. So a common element in every programming language is the concept of a variable. We have to store values such that the program can reference them during the course of its operation. So variables can contain strings, they can contain numbers, they can contain identifiers or counters. Officially, in Turing, we have strings that are a sequence of characters, and they're bound by quotation marks. We have single characters, again bounded by quotation marks, and we won't talk about these that much. We have integers, which just means a number that doesn't have any decimal places. And it's worth noting that integers are allowed to be negative under Turing rules. And we can have real numbers. These are numbers that have up to 16 decimal places. We will find that it's very useful to have the idea of a Boolean indicator, a true-false indicator. And for this, there's only two values allowed, true or false. Variable names, well, practically any string can be used as a variable name. There are a few strings that are forbidden just to avoid the possibility of confusion when interpreting code. For example, Turing won't allow us to use the string pi, and the reason for this is that Turing uses this to represent 3.14159. Okay, so again, to avoid confusion, in every programming language we have to declare variables. So variables have to be initialized to tell the program what the programmer intends to use them for. And the most common approach to this is to initialize variables at the beginning of a program. This is not strictly necessary, and there may be times when you'll decide that it's not appropriate to do that. But for the most part, people will do this, declare all their variables up front. And the var command is how Turing does this, and the syntax looks roughly like this. Notice again there's I've taken my text to look like what's in the compiler, of course, my comment that variable names are not allowed to start with numbers. Okay, and so here's some example code here where I've declared a string, I've declared an integer, I've declared a real number variable, and a Boolean variable. And I'd encourage you to keep in mind that we can use the length of strings to our advantage in order to make it very clear what we're using given variable names for. And this will help us when we're debugging code at a later point. So for customer name, we could have used the variable name N, for example, or name. But by making it more descriptive, it's easier for us to determine the role of that variable later on. Okay, so in the IDE, go ahead and open it up and initialize one of each of the 4 types of variables. Please make sure that your variable names are descriptive and include your comments as usual. Don't forget to initialize your variables. And keep in mind what this means, initializing your variables. Your initial value for a variable is often very important to the way that your program works. If you don't give it an appropriate value up front, it can cause your given logic that you build to go haywire at a later point. So it's pretty simple to assign values to a given variable. We use the exact same command that we will use later if we want to change the value for that variable. So in my case, my string is variable name equals value. And don't forget that given strings need to have quotes. Okay, so we don't have to just set the variable names through code. Quite often we'll want to get a value for those variable names from the user. And then we'll want to use that for subsequent operation of the program. So if we want to do this, remember that previously we used the simple colon equal sign to assign a value to a variable. If we want to retrieve a value from the user, we'll use the command get instead. And the catch here is that the user needs to know the type of variable and needs to input something that's compatible. Now later on when we're talking about logic, we can put in logic to protect against that problem, or we can simply prompt the user very carefully to make sure that the user complies with the variable type. And we might do this by incorporating a string that we send to the user, a put statement, that's very descriptive, so that the user doesn't get confused and give us a wrong value. So for example here, we're expecting a string. And so, well, really this is we can accept practically anything in the case of a string. If we're asking for a value, on the other hand, a number value, and the user types the value ten, instead of putting a number value in, the program will get confused. Notice though that I have simplified my code by incorporating 2 kinds of data in a single line, incorporating a variable value in my line out to the user, as well as a text string. Okay, so you can go ahead and do the same thing. Modify your program from yesterday, and you can personalize your user's interface by finding out their name and then incorporating their name into the communication with the user. So for our activity for today, please start to look at inputs, outputs, and the math that you learned yesterday, creating a simple adding machine. So prompt the user for a number, store it in a variable. Prompt the user for a second number, store that as well. And then you can display the sum of the two numbers. So you'll want to be careful to make sure that your program communicates effectively with your user, and be careful to make sure that your code is appropriately commented so that you're following proper programming procedures. And just for fun, you'll see, you can see some of the challenges that we face as programmers when we interact with users. Sometimes they'll trick us by giving us an input we don't expect. So, for example, once you have your program working, play dumb as the user and try inputting your numbers as words instead of typing the numbers. So take my example of typing 10 and 1 and observe what happens with the program. Now, if you're a little bit more sophisticated programmer, you can start to look at some error checking and things, building in some checks for that kind of situation, such that your program still works effectively when the user makes these kinds of mistakes. So go ahead and, even if you don't know which commands to use for that, once you get to that stage, go ahead and think about what you would do to correct the problem. Alright, so to summarize, variables are how Turing, in virtually every program, stores information temporarily. In Turing, there are 4 kinds of variables, each used for different things. And we use inputs to facilitate communication between the user and the program. And again, don't forget to save your programs, submitting them as the assignment for today's class. Thanks very much, and have a great night.